Can you see the slide? Naimul Hassan. Naimul, can you see the slide?
Slide দেখা যাচ্ছে স্যার।
Okay, thank you. Assalamu alaikum. So today's lecture is on ferrocement. As you can see, the structure tells that where ferrocement are used. You can see a dome type structure. Basically, it is a house. It has got an opening here. So for constructing this type of structure, ferrocement material will be used. Now we'll be seeing what is called ferrocement. What is ferrocement? The name ferrocement means can be a combination of ferrous product or cement. Ferrous product means iron, okay, in maximum cases, or welded bars, which is made of iron, or reinforcement and cement, or wire mesh, or small diameter steel mesh plus cement. So ferrocement is a building material. It is composed of a relatively thin layer of concrete which cover reinforcing material like steel wire mesh. So steel wire mesh is covered by thin layer of concrete. So that is called the ferrocement. So in ferrocement, actually it is a cement-rich mortar, mixture of cement and sand and water, and then it is reinforced with wire mesh, and sometimes additional plain wire reinforcement are added for getting strength. So according to ACI, the definition, official definition of ferrocement is: ferrocement is a type of thin wall reinforced concrete construction where usually hydraulic cement, the normal cement that we use, is reinforced with layers of continuous and relatively small diameter mesh. So this mesh may be made of metallic, other suitable materials. Normally it is metallic, but in some instances, other suitable materials are used. So you can see this type of structure, like this is a water ride. So you can see there are a lot of wire mesh and sometimes thin, small diameter iron are used, and then over which the cement paste will be placed. So for constructing a water ride like that, you don't depend on conventional concrete. You go for ferrocement structure. Ferrocement. So to sum up, it is a type of steel reinforced concrete. The basic mixture is Portland cement, normal cement, and sand. And the ratio is 3 parts sand to 1 part of cement by volume. And no larger aggregate stones are added. So it is basically cement and sand. Here, water is carefully controlled so that the mixture attains a plaster-like consistency. A mixture that is too wet, it is difficult to apply, you understand, and it forms weaker bonds to the steel. Sometimes chemical admixtures are added to change the workability. Workability means to ease with the mixture, then to accelerate or retard the setting time, to reduce the water required for getting the strength. So to reduce water, sometimes plasticizers are used. You know, when water is added, when water reacts with cement, then the hydration process starts. But okay, too much of water actually it may cause some problem, because at that time, to reduce the water, the plasticizers are used. So the job of water is to initiate the hydraulic reaction. Okay, so plasticizer does the same, but here it doesn't have water. And sometimes to increase the strength, increase adhesion. You know that the cement paste needs to adhere with the structure or the wire mesh. So some adhesive quality is to be imparted. And you have seen the picture of the water ride. Okay, so to some admixtures are used to add color, and if you make a ferrocement structure which should be water resistant, so water resistant admixture may be used. For example, acrylic, it is a plasticizer. It is used to increase strength, to increase the water resistance, and also to improve adhesion to existing concrete. Even the basic cement sand mixtures, okay, if you compare it with concrete, basic cement sand mixture, while cement is a little bit rich, it exhibits less cracking, higher strength, better adhesion, and smooth surface than traditional concrete mixtures. So reinforcement, so we said that the main matrix means actually in case of concrete, the mixture of cement, sand, and aggregate, that is the matrix. And reinforcement, the reinforcement is used within the matrix. Here, the reinforcement includes the steel layers. Number of steel layers or more in the form of reinforcing bars, and then welded wire are used, mesh are used. So together, actually, this is known as an armature. Armature means the khacha tari kara hoy. ঠিক আছে, reinforcing bar, welded wire আর mesh দিয়ে এবং number of steel layer দিয়ে একটা armature তৈরি করা হয় খাঁচা, and these layers are close to each other so that the thin shell can carry loads uniformly. In the first slide, you have seen a dome type structure, that is a thin shell structure, or the water ride is a thin shell structure. So the various layers, steel layers, are spaced very closely so that they can carry the load uniformly. And the concrete mixture, that means the plain cement concrete mixture is placed into the armature. That means the খাঁচাটা তৈরি করা হলো, সেটাতে তোমার যে it is used like plaster. আমরা নরমাল ওয়ালে যেভাবে প্লাস্টার ইউজ করে থাকি, সেখানে কিন্তু এই সিমেন্ট পেস্টটাকে আর্মেচারের মধ্যে প্লাস্টারের মধ্যে প্লেস করা হয়। And it requires significant labor because you have to prepare the armature skeleton, then you have to attach the mesh layers to the skeleton, and then you have to place the concrete. So you need a lot of labor. And there is more steel and less concrete if you compare it with the traditional reinforced concrete. In case of traditional reinforced concrete, the amount of concrete is more, the steel is less, but here the steel is more, the concrete is less. And sometimes steel can be replaced by natural fibers like bamboo. So bamboo is one kind of natural fiber, or hemp. Here you can see the hemp. Actually, this is the tree, and like our jute. Okay, so you get a fiber like that. Sometimes this fiber can be used as a reinforcement, or you do not need enough strength at that time as reinforcement. Bamboo or hemp may be used. So that is also called one type of ferrocement, though bamboo and hemp are not ferrous. Typical cross section of a ferrocement structure, as you can see on the slide. Okay, so you have one side. Okay, there is a mold, and then you place the very small diameter rod, and then the wire mesh like that, and then you place the concrete, the plain cement concrete from one side or from both the sides. So that's how a ferrocement structure cross section looks like. A typical cross section of ferrocement structure. So here you can see, as I said, that the steel rods or the wire mesh are closely within the wire mesh. The wire are closely spaced. Maybe the spacing is so close, it is 1/4 to 1 inch. That may be the spacing of the rod, or if you look in this way, in transverse directions. So the spacing of the rod may be ½ inch to 2 inch. So that is the actually the thickness of the ferrocement structure. We may say it is 2 inch or less, 50 millimeter or less, very thin. This is very, very important for all types of exam. Failure of ferrocement. What is the mechanism of failure mechanism of ferrocement structures? Very important. The most common causes of failure of ferrocement and also reinforced concrete is the corrosion in steel and incomplete mortar penetration. So corrosion is a common cause of failure for concrete, and this is also applicable for ferrocement structure. And another cause of failure is the incomplete mortar penetration. You know, in case of ferrocement, the wire meshes are very closely spaced. Then you have to place the mortar inside. So if the mortar cannot penetrate inside the wire mesh, so that incomplete mortar penetration may cause failure. And then a lot of reinforcements in the form of steel wires, wire mesh, or welded rods are used. So these will be subjected to corrosion, rust. So what happens when rust is formed? Rust is nothing, a formation of metal oxide over the reinforcement. So it expands, and then it exerts pressure on the cover concrete, and that's how the concrete cracks. So when the concrete cracks, it allows air or water from the environment to reach to the steel, and then the corrosion cycle is repeated. So it is a destructive cycle. The destructive cycle continues. The most common causes of corrosion are internal air pockets and exposed steel, as the thin shell actually thickness is only less than 2 inch. So that means the concrete cover is very less. So it is very easy from the environment for the water and air to get inside. And sometimes it may not be possible to place the mortar inside that complicated wire mesh arrangement. So there remains some air pockets, and some steel may be exposed. And subsequently, what happens due to the presence of these air pockets and exposed steel, the corrosion takes place. So corrosion is more in ferrocement than in conventional concrete. Now, the air pockets, the issue of air pockets can be solved if you vibrate the concrete right after pouring, or if you manually push the mixture, okay, as it is done with the help of the trowel. Trowel means ki আমরা কি বলি যে মানে যে trowel কি কোনই বা কোনটি এটা যেটা আমরা trowel দিয়ে প্লাস্টার করার সময় আমরা trowel ইউজ করে থাকি, ঠিক আছে? So if you use it properly, so that means it depends on skill levels required, okay, that can reduce the presence of air pocket. And concrete cover is always required for any steel, and so that the steel is not exposed to atmosphere. So in case of conventional concrete, or when you construct the beam or the column, normally 1.5 inch to 2 inch clear cover concrete is placed, but here actually the concrete cover is less. Okay, and in feather cement, the outermost mesh is close to the surface. So, when the part of the concrete which is close to the surface, that means close to the ground, so that will be subjected to more amount of corrosion because it will be subjected to water, and then from water there may be sulfate or chloride may get inside. It is better that the outer mesh, which is close to the surface of the feather cement structure, should be galvanized steel. So galvanized steel, okay, which is corrosion resistant to some extent. Now the failure mode. The failure mode of feather cement structure is different from standard reinforced concrete. So if a large impact or point load, okay, comes on the thin shell of feather cement structure, so it will cause the feather cement structure to deform, or sometimes it buckle, and that results in cracks over a wide area. So that means the structure will remain intact, so it will not collapse. In case of conventional concrete, okay, due to the load, obviously the load will be more. In case of conventional concrete, actually the conventional concrete may break or crumble or delaminate, okay, and it may cause the structure to fail. But in case of feather cement structure, due to the presence of number of reinforcements, okay, and due to the impact load or point load, actually the thin shell will deform or buckle. Okay, it will not fully collapse. The constituent materials of feather cement, as you can see on the slide: cement, fine aggregate, water, admixture, mortar mix, reinforcing mesh, skeleton steel, and coating. So you'll be seeing one by one these constituent materials. So specification of materials as per BNBC 2020 cement. So, the normal cement we used. The cement shall comply according to BNBC 2020 with BDS EN 197-1. So this is an European standard which defines and gives the specification of different types of cement and their constituents. Normal cement, sulfate resistant cement, okay, and then okay, various types of cement. So there are European standards. So BDS, so the cement that is used in feather cement structure, it should be equivalent to BDS EN 171 or equivalent standard. And the cement shall be fresh, it should be of uniform consistency, it should be free of lumps and foreign matter. What is lump? Because in cement, lumps are formed because when there are high moisture content available in the environment, so when the cement is stored in humid environment for a longer period, at that time, lump, that means steel spheres are, cement spheres are formed. So the cement should be free of that lumps, and it should be stored under dry conditions and should be stored for as short as duration as possible. But because here the quality of cement is very, very important. Now the choice of a particular cement. What type of cement? In cement, we learned about various types of cement. So what type of cement we should use, that will depend on the service conditions. That means the structure where it will remain. The service conditions can be classified as electrochemically passive or active. That means electricity and then chemical reactions. Okay, so the environment may be passive, or the indirect effect, or the environment may be active. So basing on the service conditions, that means where the feather cement structures will be placed. So the cement type of cement actually that you are going to choose, that will depend on that. For example, land-based structures like feather cement silos means storage, or then bins and water tanks. So they can be considered as passive structures, except when in contact with sulfate-bearing soils. Because if these structures are in contact with sulfate-bearing soils, in that case, sulfate-resistant cement such as STM type 2 or type 5 may be necessary. So we are talking about cement, the cement which is required for feather cement structures. Then other types of cement like blended hydraulic cement conforming to STM C595 type 1 PM, IS, or SM, ISA, IP, IPA can also be used. So these actually STM is the standard. STM C595 is a standard, and PM, IS. What is IS? IS is a Portland blast furnace slag cement. What is IP? IP is a Portland pozzolan cement. Then PM is pozzolan modified Portland cement. What is SM? The slag modified Portland cement. So blended hydraulic cement, if it conforms to STM C595 standard, that can be used. Mineral admixtures like fly ash, silica fumes, or blast furnace slag may be used to maintain a high volume fraction of fine filler material. So we said that cement is used, sand is used, but you can use some filler material also, like fly ash, silica, and blast furnace slag. And when these are used, mineral admixtures, if the mineral admixtures are used, like fly ash, silica fume, and blast furnace slag, they shall comply with the STM C618 and C989. Okay, these are the standards. While it is said that actually what should be the specification of the mineral admixtures. In addition to the mineral admixtures has some role. In addition to improving the flowability, they also contribute to gain long-term strength and also lower mortar permeability. And in some cases, they improve resistance to sulfate and chlorides. So mineral admixtures are used to gain this benefit. Now, regarding aggregates, so aggregate used for cement are normal weight fine aggregates, normally sand. And the sand, the specification of sand shall comply with STM C6 requirements of fine aggregates or an equivalent standard. And sand should be clean, inert. Inert means the material does not take part in any chemical reaction. It should be free of organic matter. Then it should be free of deleterious substances, harmful substances, and should be free of silt and clay. Because silt and clay will actually reduce the purpose, will not serve the purpose of the sand. And the maximum particle size shall be controlled by construction constraint like mesh size. So mesh are closely spaced, and you have seen that the mesh are spaced, the rods are spaced from 1/4 inch to 1 inch, this spacing. And the distance between, and there are various layers of mesh are used. And between the various layers, a distance is maintained. And altogether, the thickness is 2 inch. So the particle size, that means the aggregate that you are going to use. So these are actually controlled by this mesh size and the distance between the layers. For aggregates, maximum particle size passing sieve number 16, that is 1.18 mm, may be considered appropriate in most applications, most cases. And the grading of fine aggregate, that means the sand, shall be in accordance with the guidelines of the table. So this is the guidelines for grading of sand. Here you can see, we talked that number 16 sieve, that is 1.18 mm sieve. So 50 to 85% passing through the sieve, actually those sand should be used for cement structures. And aggregates that reacts with alkalis in cement, okay, in cement there are some alkalis, shall be avoided. So when aggregates may be reactive, they shall be tested in accordance with STM C-201. So aggregate should be tested whether they're reactive or not. So some standard procedures are there in STM C-201. And if it is found that they're reactive, so you have to use a pozzolan to suppress the reactivity, okay, and then it should be evaluated again in accordance to the STM C-441. So ferrocement structures, what I want to say that the quality control is very, very important. It's not that you take cement and then you place it over the wire mesh. So here the choosing of the cement, the type of aggregates, the aggregate properties, it should follow the STM standards. Otherwise, you not get the standard for cement structures, because this is actually requires very fine care in selection of materials. The water, the mixing water shall be fresh, clean, and potable. Okay, you understand? Then water should be free from organic matter, silt, oil, sugar, chloride, and acidic material. And water should have certain pH level. What is pH? pH is a measure of how acidic or basic water is. The range of pH normally varies, by this time that it varies from 0 to 14, but 7 is neutral, and pH less than 7 means acidic, and pH over 7 means it's alkaline or base. So it should have a pH value greater than 7, so that the water is not acidic in nature. Because if the water is acidic in nature, so actually there will be more amount of hydrogen to take part in chemical reaction. Okay. And salt water is not acceptable, but chlorinated drinking water can be used. In terms of admixtures, conventional and high-range water reducing admixtures like super plasticizers are used, and they shall conform to STM C49486. In case of water reducing admixtures, they will result in lower shrinkage and less surface crazing, the formation of fine cracks. What happens? You can use water, no problem. But you know that if you use water, then the reaction between the cement and water, it takes some time, and then subsequently shrinkage and other issues may come up. So to reduce the use of water, you can use water reducing admixtures, so that you don't have water, but with the use of admixtures, you get the functions which water is supposed to do. If water tightness is important, okay, normally when you make water or liquid retaining structures, okay, at that time, waterproofing coating is applied. So this is one type of admixture. We use mineral admixture. We say the fly ash. The fly ash actually it should conform to STM C61885 standard, and it can be added to cement to increase workability and durability both. Normally, 15% of the cement can be replaced with mineral admixtures. So instead of cement, normally instead of cement you use mineral admixtures, and cement has got a proportion. For example, 3 parts cement, 3 parts sand, and 1 part cement. Then in 1 part, if you make it to 100, then 15% can be replaced with mineral admixtures. Okay. And for pozzolanic admixtures may be added to replace part of the fine aggregates to improve plasticity. Pozzolanic admixtures means it will create bond or it will increase the cementitious capacity. In terms of reinforcement, the reinforcement should be clean and free from deleterious materials or harmful materials like dust, loose rust, then coating of paint, oil, or similar substances. Wire mesh, so you can see the wire mesh. Actually, this is the wire mesh, which with closely spaced wires is the most commonly used reinforcement for cement. So for cement, wire mesh use করা হয় সবচেয়ে বেশি, এবং যেখানে তোমার ওয়্যারটা খুব ক্লোজলি স্পেস থাকে, ওয়েল্ডেড ওয়্যার ফেব্রিক ইউজ করা হয় sometimes. So this is not wire mesh, this is welded wire fabric. Then expanded metal mesh, it was expanded metal mesh reinforcement ইউজ করা হয়, বার ওয়্যার আর প্রি-স্ট্রেসিং স্ট্যান্ড ইউজ করা হয়, অথবা instead of those ferrous materials, you can use the fiber reinforced polymer. In next class we'll be talking about fiber reinforced polymer. Okay, so discontinuous fibers, that means fibers are just cut and then placed in random orientation, or other forms of non-metallic reinforcement may be used. Okay, and besides traditional welded wire fabric or metal mesh reinforcement or metal bars and wires, you can use those discontinuous fibers or non-metallic reinforcement as reinforcement for the ferrocement structure. So reinforcing mesh, bar can be used, square mesh can be used, expanded mesh can be used, or hexagonal mesh can be used. Reinforcing mesh, so that means okay, the iron bars are placed closely spaced. Okay. The steps in ferrocement constructions. There are 4 steps, simple. At first, you place the wire mesh in proper position. Then you mix the mortar and apply the mortar, and then we allow it to cure. If you go into the details, so ferrocement structures actually have a desired shape. For example, if you want to make a water ride, or if you want to make a sunshade, or if you want to make a dome type of structure, so desired shape may be built okay, from a multi-layered construction of chicken wire, and if needed, it should be reinforced with steel wire or steel bars. And over this framework, actually, then you apply the mixture of cement, sand, and water, and then it will be subject to hardening. So during the process of hardening, the ferrocement should be kept moist, the curing, normal curing that we do in other the conventional concrete, so that the cement is set and it gets hardened. In the construction methods, there are various. We talked about the armature. Armature means the wire mesh or chicken wire or the welded wire দিয়ে আমরা যে একটা armature বা খাঁচা তৈরি করব, সেই arrangementটা it can be 3 or 4 types of arrangements are there. One is called armature system. So the armature system is a framework of tied reinforcing bars, the skeleton steel. So if you can see in this slide, so here the skeleton steel is there, basic structure, okay, and with that you tie up okay, different layers of reinforcing mesh, okay, on each side. So skeleton steel is at the middle. Then with that you attach the reinforcing mesh on both sides, but mortar is then applied from one side and forced through the mesh layers to the other side. So this can be one arrangement. This is called the armature system. There can be another arrangement like closed mold system. Here, the mortar is applied from one side, so several layers of mesh and rod combinations, so which has been stapled or others held in position against the surface of a closed mold. So you have got a mold, and then with the mold, you have placed the wire mesh, and then you are applying the plasters from one side. So that is called a closed mold system. Then you may have integral mold systems. Here you use a mold, and that mold remains. And on both sides of the mold, you use the steel wires and wire mesh, and the plasters are placed, okay, from each side, okay, from both the sides. So this is called the integral mold system. Here the mold remains. And this is called open mold system. In an open mold system, mortar is applied from one side through the layers of mesh or mesh and mesh rods. Okay, so that may be various arrangements how you place the mortar into the armature, and sometimes some molds are used, some molds are used, and the molds are removed later on. Some molds remain in position. Okay, so that can be various arrangements. Why do you use these ferrocement structures applications? So for buildings, not conventional high-rise buildings, but maybe 1-story or 2-story buildings, or bus shelters, where you need to give an aesthetic view. Then breeze decks sometimes, okay, are made of ferrocement structures. Then concrete road repair, you can use ferrocement. Then factory-built homes. Then food and water storage containers. Then irrigation structures. Then when you create some sculptures, so you can use ferrocement. Then if you want to repair some artifacts, at that time you can use ferrocement. Then boats and ships, actually that can also be made by ferrocement. I've seen a picture, must be a picture of Denmark, I forgot. So they had a boat made of ferrocement structures. So it had buoyancy, okay, made before 1 century. So people used to make boat, okay, with the ferrocement structures. Then retaining walls and traffic caution signboards sometimes are made with ferrocement structures. And it is best suited for making compound carved structures like domes. So dome is a compound carve. Then ship hulls, shipper যে বডিটা আছে সেটা অনেক সময় ferrocement structure তৈরি করা হয়, though nowadays they are being replaced Earlier it is to be used, now it is being replaced by other high quality, high strength, lighter materials. So you can see that in housing, in the roof part, so ferrocement structures are being used, where you don't use a heavy roof, okay? Then a water supply. So so this is a tank, water tank, which is made of with the technology of ferrocement structures. Then agricultural, suppose this is a water storage from where water will be used for irrigation purpose. So this is the structure where if you look carefully at this slide, you can see that the lower base concrete with mesh, this one, the upper base, okay, with upper base concrete with mesh. So between these two, you have got the mortar, ceiling mortar, and then you can use the flint coat. So that will make the whole system the watertight. So this is the commercially available flint coat. So those agricultural structures which are used for irrigational purposes, it contains water, okay, and this is the ground. So actually you can use ferrocement materials. Agricultural structure like this, water storage, water tanks can be made of ferrocement structures. Why it is preferred? We'll see later. We will see later, because when the crack develops, so since the ferrocement structures are made of very closely spaced the reinforcement bars, okay. So when the cracks develops, the cracks widths are very what should I say? Crack width গুলো হচ্ছে তোমার খুব thin. Now conventional concrete যদি crack develop করে এটা একটা বড় হয়ে যায়. But ferrocement structure, since the reinforcement are closely spaced, so এখানে যদি crack হবে numerous, crack width হবে কম. এই জন্য তোমার ওয়াটার রিটেনিং স্ট্রাকচার হিসেবে এটাকে প্রেফার করা হয়, ওকে, লো স্কেল বা তোমার যে ইমপ্রোভাইজড কন্ডিশনে যখন ইউজ করা হয়, রিমোট এলাকাতে যখন ইউজ করা হয়, তখন ferrocement structure is a good solution. Okay, some residential and public buildings are made. Here you can see. So this building is made based on ferrocement structures. It's not necessary that whole building is made of ferrocement structures, but maybe some part is made of traditional concrete and some part where you need to give a compound curve like that. So, and then you have to make a shape like this. That you can use this compound curve shape, which is very thin wall. Okay, so that you can make with the help of ferrocement technology. Water right. So you can see this water right. So here you see a lot of reinforcements, okay, and also the armature, and where the plasters will be plasters, that means cement and sand and water, that paste will be placed here on this armature later on. And maybe this sometimes you can use as sunshade. So sunshade, you see, it doesn't have thicknesses less than 2 inch. So this can be a ferrocement structure. So this part is okay. It can use load, but this part actually will not take that much of load, but it can act as sunshade. So for act as sunshade, ferrocement structure is okay. So you can save money by avoiding construction of conventional concrete sunshades. Ferrocement houses built in Mexico. So okay, house. So you see, if you make a ferrocement structure, okay. So with conventional concrete, actually you cannot make this type of structures. So thin shell and use of compound curve. So you can give any shape. So the armature. So the main thing is the armature. The khachara tori korcho, seta দিয়ে you can give any type of shape. এই shapeটা তোমার দেওয়া যেতে পারে. So if you use the ferrocement technology. Okay, this is the inside view of that house. Okay, some of you may dream to make a house like that, if you have the passion for that. Ferrocement houses built in Mexico, the Mexican whale house. Actually, these are made in areas in park or amusement parks, okay, where the tourists or the kids they enjoy, okay. So for making these type of structures, actually you use ferrocement technology. Here you can see a large dome house in Florida. They claim okay, that this structure survived hurricane, Ivan in 2004 and Hurricane Dennis in 2005. That means they wanted to say that they wanted to mean that is the ferrocement structure can be very strong. You know, for conventional concrete, there are specifications are there. Okay, SCI, STM, and then okay, there are various standard codes are there. Codes are there, specifications are there, and conventional engineers they follow those codes. For ferrocement structures, actually, the presence of codes, okay, are not that much strong. Okay, though in aggregate part or in cement part, okay, and in admixture part, we referred some STM standards, but still, those who can যারা এই ধরনের জিনিস করতে পছন্দ করে বা যেখানে এই ধরনের জিনিসের দরকার আছে সেখানে তোমাকে ferrocement is the option. Advantage, ferrocement advantage গুলো হচ্ছে এটা weight কম, you understand, and maintenance cost also কম, and long lifetime in comparison with steel constructions. Here I doubt, though actually, you know, those who advocate for ferrocement, they normally show a lot of advantages and normally they hide a lot of disadvantages when they compare it with conventional steel structures or conventional concrete structures. So low weight is okay. The maintenance cost is an advantage. I'm in doubt. And long lifetime may not, because I don't think that it will have long lifetime, though in the slide it has been shown as an advantage in comparison to steel constructions. Because we know that previously discussed that ferrocement has got only a thickness of 2 inch, while the steels and subjected to corrosion, and there are air pockets and air bubbles. So these are subject normally supposed to be actually less, supposed to have less lifetime in comparison to steel constructions. However, they have listed it as an advantage. And when a ferrocement sheet is mechanically overloaded, it will tend to fold instead of crack or rupture. যখন overload করা হবে, fold করবে কিন্তু। কারণ the wire framework will, the framework যেটা হচ্ছে continuous wire দিয়ে, or closely spaced wire দিয়ে, or different layers of wire mesh দিয়ে, it will hold the pieces together, okay, and which in some applications, for example, boat hull, boat যে bodyটা বা ceiling to advantage. A ferrocement construction has 10 to 20% of the weight of a comparable construction made of bricks. That is true. A brick structure ferrocement structure weight on come হবে, and construction is easy. Construction is easy, but actually method is very easy. But actually, you also don't need the skilled labor, but it is a labor-intensive work. Only labor can just lag. And the building techniques are simple enough, as I said, and unskilled labor can do it. And that's why the ferrocement is an attractive construction method in areas where labor costs are low. So in Africa, in part of Asia, okay, in the remote areas, so ferrocement is one option where actually they want to reduce the construction cost. And also, in the developed countries like in USA, in the remote areas, in some of the farmhouses where they store their food grains, okay, so they make ferrocement structures. Sand, cement, and water, these are the constituent materials of ferrocement. So they can be obtained locally from anywhere, and the cost of reinforcing materials like steel rods, mesh, pipe, chicken wire, spare materials, so these are minimum in comparison to conventional concrete. And there is no need for the complicated framework of reinforced cement concrete, RCC. RCC is the cushion that you have to take because the amount of load it will be taking. So framework is complicated. So reinforcement frameworkটা ফরম্যাটটা এখানে অত বেশি ফরম্যাট লাগছে না, স্কেলেটনের জন্য যে লাগছে সেটা দ্যাট ইজ ডিফারেন্ট থিং। এখানে তো আমার কোনো কমপ্লিকেটেড ফরম্যাট লাগছে না, ওকে, বা স্টিলের যেমন একটা ওয়েল্ডিং লাগে এখানে আমাকে ওয়েল্ডিং লাগছে না। সো দে সে দ্যাট দিস ইজ অ্যাডভান্টেজ ইন কম্পারিজন টু কনভেনশনাল কংক্রিট, এন্ড ভার্চুয়ালি এভরিথিং ক্যান বি ডান বাই হ্যান্ড, কোনো মেশিন লাগছে না কিন্তু এখানে। সো দিস আর দ্য অ্যাডভান্টেজ অফ ferrocement স্ট্রাকচার্স। Oh, they have some more advantages. Ferrocement can be shaped in any form. This is true. It can be formed into sections less than 1 inch thick and assembled over light framework. The light framework base করা যায়. It is rot proof, impervious to warmth and watertight. Okay, this is true when we compare ferrocement structures with the timber structures. Timber is যেমন rot হয়, তারপর তোমার it is impervious to warmth and that is not watertight. So if you compare with timber structures, so then this is true. The ferrocement is more adaptable than RCC and can be formed into simple or compound carbs. So that is understood. In third world countries, ferrocement is almost always economically competitive with steel, wood, or glass fiber reinforced plastic constructions because steel and FRP are expensive and wood is becoming more and more scarce. So in third world countries, যেটা বলেছি, ferrocement structure-টা বেশি দেখা যায়. Disadvantage হচ্ছে যে অনেক বেশি লেবার লাগে, labor intensive nature, and it is a labor intensive nature. So that may be a disadvantage for the developed countries where labor price is very high, but in underdeveloped countries labor intensive হলে সুবিধা, ঠিক আছে, কারণ তখন এখানে labor is cheap, so ferrocement structureর জন্য labor intensive হলে কোনো সমস্যা নাই. So that is not a disadvantage for underdeveloped countries. So that may be expensive for in West. And structures made of it can be punctured by forceful collision with pointed objects. So the thickness যেহেতু খুব কম, যদি pointed object যদি সাথে collision টা হয়, so it may be punctured. That is one disadvantage. And major disadvantage is that in corrosive environments, for example in seawater সাথে যে স্ট্রাকচার গুলো থাকে সেখানে corrosion খুব বেশি হয়. It is often seen that after several decades the reinforcing materials become corroded. After not even several decades, after few decades. Normally, তুমি যখন sea environment-এ conventional concrete structure-এর ভিতরে কিন্তু reinforcement-এর মধ্যে corrosion কিন্তু হয়ে যায়. So ferrocement-এর বেলা এটা একটা আগে হবে. So once you make ferrocement structures, so you avoid that environment. Corrosive environment-টাকে avoid করতে হবে. সেখানে সব করলে long the life structure that you will not get. It is generally impossible to fasten objects to ferrocement with bolts or screws because drills usually break against the lac. মানে normal একটা concrete wall-এ তুমি drilling করে you can hang something, একটা switchboard লাগানো যাবে, একটা ঘড়ি লাগানো যাবে, হ্যাঁ, you can do anything. But ferrocement structure thickness তো 2 inch, সেখানে drilling করে কিছু লাগানো যাবে না, এটা বলা হয়েছে disadvantage. Properties. They claim that it has got toughness, ductility, durability, strength, and crack resistance that is considerably greater than that found in other forms of concrete construction. So concrete সাথে 1-to-1 comparison করা যাবে না, ঠিক আছে, বাট কিছু কিছু জায়গায় তোমার এই প্রপার্টিজ গুলো পাওয়া যাবে. And these properties are achieved in structures with a thickness that is generally less than 25 mm. So normal concrete তো তুমি 25 mm এর কোনো তোমার স্ট্রাকচার তৈরি করতে পারবা না. So in that case, so বলা হচ্ছে যে the toughness, ductility, durability, strength, and crack resistance are comparable. Okay. Tensile behavior. So reinforced concrete tensile behavior among ferrocement tensile behavior is different because in case of ferrocement, the reinforcement is spaced closely and uniformly. Okay, and then it has got a small diameter. So small diameter মানে হচ্ছে specific surface কিন্তু অনেক বেশি. So এটার জন্য যেটা হয় ক্র্যাকিং বিহেভিয়ারটা ডিফারেন্ট হয়ে যায়. এই জন্য বলেছিলাম যে ফেরোসিমেন্টে যে ক্র্যাক ডেভেলপ করে সেটা হচ্ছে ফাইন এবং এটা হচ্ছে তোমার মোর নাম্বার অফ ক্র্যাকস আর ডেভেলপড, ঠিক আছে, ফেরোসিমেন্টে. বাট ইফ ইউ কম্পেয়ার ইট টু কনভেনশনাল কংক্রিটের তুলনা করলে ফেরোসিমেন্টের ক্র্যাকটা হচ্ছে তোমার ক্র্যাকের সংখ্যা বেশি, বাট ক্র্যাক উইডথ ইজ ভেরি স্মল when it is subjected to tensile load. Compressive strength. So high compressive strength of mortar contributes primarily to the compressive strength of ferrocement composite. So the use of welded wire mesh. So এখানে যদিও compressive strength তো আমরা নরমাল কংক্রিটে পাই বা সিমেন্ট থেকে, এখানে কিন্তু ferrocement স্ট্রাকচারে welded wire mesh তোমার কিছুটা compressive strength contribute করবে due to the lateral restraint provided by the welded transverse wires. The welded যে যখন করা হয় welded transverse wires এর জন্য lateral restraint থাকে বলে কিছু compressive strength এখানে পাওয়া যাবে এটা. বাট এটা আবার কিন্তু হেক্সাগোনাল মেশ যদি তোমার ওয়েল্ডেড না হয়ে হেক্সাগোনাল মেশ হয় অথবা এক্সপান্ডেড মেটাল যেটা আগে দেখানো হয়েছে, তো সেখানে কিন্তু তোমার যে এই কম্প্রেসিভ স্ট্রেংথের এই অ্যাডভান্টেজটা পাওয়া যাবে না, কারণ এখানে লংজিটিউডনালি স্প্লিট করে যাবে। Flexural strength, ferrocement may be subjected to flexural strength. Okay, so if you compare it to reinforced concrete beam, normally concrete beam গুলো কি হয়, এগুলো তোমার আন্ডার রিইনফোর্স থাকে। কেন আন্ডার রিইনফোর্স থাকে? বিকজ যদি এগুলো ওভার রিইনফোর্স থাকে তাহলে যেটা হবে যে কংক্রিট আগে ফেল করে যাবে, এবং ফেলিউর অফ কংক্রিট বিফোর তোমার যে রড, দ্যাট ইজ ভেরি ডিভাস্টেটিং এন্ড ফ্যাটাল, ক্যাজুয়ালিটি বেশি হবে। এই জন্যই তোমার নর্মাল কনভেনশনাল তোমার যে কংক্রিট ওয়ার্কে তোমার যে আন্ডার রিইনফোর্স থাকে, আন্ডার রিইনফোর্স হলে কি হয়, ক্র্যাক ডেভেলপ করে। ক্র্যাক ডেভেলপ করলে মানে যে রিইনফোর্সমেন্টটা যখন ফেল করে তখন কি হয়, কংক্রিটে ক্র্যাক ডেভেলপ করে, দ্যাট গিভস এ সাইন, এই জন্য আন্ডার ডিজাইন। বাট ফেরোসিমেন্টের বেলায় যেহেতু অনেক বেশি লেয়ার অফ ওয়্যার মেশ ইউজ করা হয়, সো নর্মালি এটা ওভার ডিজাইন। সো এখানে ওভার ডিজাইন কিন্তু ইজ নট এ প্রবলেম, কারণ এখানে কিন্তু ওভার ডিজাইন হলেও এখানে যে তোমার যে ইয়া থাকে, যে তোমার যে সিমেন্ট মর্টার থাকে, এটা পড়ে গেলেও কিন্তু কোনো সমস্যা নাই, ঠিক আছে। তো এই জন্যই flexural strength, if you compare it, conventional concrete is a little bit different and safer. And tests were performed on ferrocement beam with difficult volume fraction of reinforcement. Reinforcement ভ্যারি করে তোমার ট্রান্সভার্স শেয়ার চেক করা হয়েছে, এবং এটা দেখা গেছে যে শেয়ার স্ট্রেংথ ডিপেন্ড করে তোমার মর্টারের উপরে, ওয়্যার স্ট্রেংথের উপরে, তারপরে ভলিউম কি পরিমাণ সিমেন্ট, কি পরিমাণ তোমার রিইনফোর্সমেন্ট ইউজ করা হচ্ছে তার উপরে, শিয়ার স্প্যানের উপরে, এর উপর তোমার শিয়ার প্রপার্টিসটা ডিপেন্ড করে। ইম্প্যাক্ট রেজিস্ট্যান্স, মেশের তোমার স্পেসিফিক সারফেস, মানে যত বেশি মেশ হবে ওয়্যার মেশ এবং মেশের স্ট্রেংথ যত বেশি হবে, তো ইম্প্যাক্ট লোডিং হলে তার ইম্প্যাক্ট অত ড্যামেজ তত কম হবে। একটা ডিসঅ্যাডভান্টেজ ফেরোসিমেন্টের স্ট্রাকচার হচ্ছে তোমার ফায়ার রেজিস্ট্যান্স। আমরা জানি যে কংক্রিট কিন্তু বিটুইন স্টিল স্ট্রাকচার and concrete structure, concrete is better in terms of fire resistance. হ্যাঁ, কংক্রিট কিন্তু কংক্রিট একটা ওয়াল অফ ওকে বা একটা ব্রিক ওয়াল, এটা কিন্তু অনেক লং টার্ম ধরে ফায়ার রেজিস্ট্যান্স দেবে কিন্তু। বাট ফেরোসিমেন্ট স্ট্রাকচার which is only 1 to 2 inch thick, so এটা তোমার পুয়ার ফায়ার রেজিস্ট্যান্স, ওকে, because the structure is such, এবং এটার মধ্যে তোমার যে কংক্রিট কাভার বলতে কিছু থাকেই না। So in fire resistance, this is a major disadvantage. Okay. And then durability. So okay, cover just small cover just concrete cover just কম থাকে, okay, based on exposure conditions, durability is affected more than normal RCC. But যদি তোমার ম্যাট্রিক্সটা যদি fully compacted হয়, এবং if you use protective coating, so at that time the problem of durability may be overcome. Corrosion is a major problem for cement, especially if the structure is made in main structures, because এখানে তোমার যেটা হয়, তোমার যে এনভায়রনমেন্ট থেকে তোমার যে ক্লোরাইড বা সালফেট এগুলো কিন্তু এন্টার করে এবং করোশন রেটটাকে অ্যাক্সেলারেট করে দেয়, ঠিক আছে। আর কারণ মর্টার কাভার তো মার্কেট নাই বললে চলে, ওকে, এবং স্টিলের পরিমাণটা খুব বেশি, সো corrosion is a problem for cement structures. Water retaining capacity, it is good. It is a special property of cement যে water retention করতে পারে for at least in case of liquid storage tank, okay, because কারণ যেটা একটা পিকচার দেখেছিলাম যে লিকুইড স্টোরেজ ট্যাঙ্কে cement structure is preferable to some extent, because এখানে ক্র্যাক উড যেটা ডেভেলপ করবে সেটা হবে স্মল ক্র্যাক উডস, সো লিকেজ যেটা হবে সেটা হবে খুব মিনিমাম। That's all about the cement structures. Thank you. Any question from your side? Okay, thank you.